In this video, we're going to be going over how to do noble gas configurations and also going over a few examples. Now to start, it's important to know where your noble gases are located on the periodic table. They are located here on the right, so you have helium, neon, argon, and krypton as your main four that you will be using for most of your configurations or notations. And sometimes you use xenon and radon, but those usually aren't used as much because those are in the higher energy orbitals. So now how to do a noble gas configuration. What you want to do is remember how to get our energy levels of our orbitals. We draw out the little diagram here. Like so. And then we draw the arrows down to figure out the order. And in this case, we can also do the 5 orbitals. So if we were to have an element, let's say fluorine, for example, the electron configuration of this would be 1s2, 2s2, and 2p5 to get the 9 electrons. We can see that it has here. But now, what if we wanted to write this in noble gas configuration? Well, we need to take a look at the noble gas before fluorine, in which case it would be helium. So we write helium in brackets like this. And then we take the orbitals that have n equals 2, and we write those after it. So 2s2 and then 2p5. And that would be fluorine's noble gas configuration right here. And there are a few exceptions to the noble gas configuration or notation rule that we have. So the two exceptions are chromium and copper. The reason for this is that one electron in the 4s orbital gets excited and moves to the 3d orbital to either fill it halfway or to fill it fully. The half-filled d shell is for chromium, the fully filled shell is for copper. So let's take a look at what the notation would be. The noble gas notation would be for chromium to start. So looking at a full periodic table, we have argon being the noble gas that is before chromium. So we can write argon, and then we write 4s1, and then 3d5. Because notice how it is 1, 2, 3, 4, 5, 6. It is the 6th one in that row, which means that it will have 6 electrons after argon. So 1 plus 5 is 6. So this is for chromium. And now moving on to copper. Copper also has the argon notation to start, and it also has that 1 electron excited to the d orbital. So that's copper. Now we are asked to write out the electron configuration and noble gas configuration for the element of gallium. And gallium is located right here in the periodic table with an atomic number of 31. Let's just write that out on the side here. So that means that gallium has to have 31 electrons in its complete electron configuration and noble gas configuration. So starting off with the electron configuration, which is all of the orbitals written out with all of their filled shells or partially filled shells. So we're going to use our chart on the right to help us out, starting with the 1s completely filled, 2s completely filled, the 2p orbital completely filled, and the 3s completely filled, and then we go into 3p completely filled, and then 4s also completely filled, and then the 3d is also going to be completely filled, but the p orbital is only going to have that 1 electron. So this is our complete electron configuration. And now to do the noble gas configuration, all we need to do is to look at the previous noble gas element in the periodic table, which would be argon here. So we write argon in brackets, and then we just take all of the orbitals after the 4s orbital, because we know that the 4s starts with potassium and cadmium here. So we write 4s2, 3d10, and 4p1. So this is noble gas configuration down here, and the one above is the complete electron configuration. But we can see how the noble gas configuration is easier and quicker to write, so teachers are going to ask you how to do the noble gas configuration over the complete electron configuration, especially for the elements that have a lot of electrons here. And now this question is asking what element on the periodic table has the noble gas configuration of neon and a 3s orbital completely filled and a 3p orbital partially filled. And it is also asking what is the electron configuration and how many protons, neutrons, and electrons does this element have. Okay, so this is a pretty easy question. So we know that it starts with neon, and here is our 3s orbital here with sodium and magnesium, and then we count 5 electrons after that for the 3p orbital. So we have aluminum, silicon, phosphorus, sulfur, chlorine. So chlorine is going to be our element here, and it wants its complete electron configuration as well. So we're going to write that out below here. So we have 1s orbital completely filled, 2s completely filled, 2p completely filled, and then we just write that last little bit of the noble gas configuration. So that is the electron configuration. And now it's asking how many protons, neutrons, and electrons does chlorine have. This is just a bonus question. If you want to know more about how to get the number of protons, neutrons, and electrons, check out my previous video. So in order to get to the number of protons, we need to look at the atomic number, which is 17. So 17 is number of protons. And now if we remember, protons plus neutrons gives us the atomic mass of chlorine, which in this case would be 35.45, which is the average atomic mass. So 35.45 is equal to protons plus neutrons, but we're going to simplify it down to 35 to get whole numbers here. And we know that there's 17 protons, so that means the number of neutrons has to equal 18. And now because chlorine is in its neutral state here, there's no charge on it, the amount of electrons will equal the number of protons, so the number of electrons will also be 17. And that is how you do the noble gas configuration, the complete electron configuration, and also determine the protons, neutrons, and electrons of an atom given the noble gas configuration. And one final question, which is very similar to the last one. What element on the periodic table has the noble gas configuration of argon and a completely filled 4s orbital, a 3d orbital, and a half-filled 4p orbital? And what is its electron configuration? And finally, we are going to look at how to determine the number of protons, neutrons, and electrons. So using the same strategies from before, we're going to look at argon, and then we're going to look at the elements below that to determine which element we're dealing with here. So here is the 4s orbital completely filled. Here is the 3d orbital, I'll write that out right there, completely filled. And we can only have 3 more electrons after this, which gives us arsenic, which is also As. And it is now asking what is its electron configuration. So we're going to write out the entire thing, starting with the 1s orbital. 2s is completely filled, 2p, 3s is filled, and then we move to 3p as well, and then 4s, 3d is filled, and then the p orbital is partially filled. So that is its complete electron configuration. And now we are asked how many protons, neutrons, and electrons it has. So from before, the number of protons is equal to the atomic number, which is 33, so protons is equal to 33. Protons plus neutrons is equal to the atomic number, which is close to 75. And we know that the number of protons is 33, which means the number of neutrons has to equal 42 to get 75. And the electrons, because arsenic is in its neutral state with no charge, has to equal the number of protons, which is 33. I hope you found this video helpful. If you did, consider leaving a like or consider subscribing to the channel.